So here's the data for our very first mass trial. The mass on the end of the string was about 50 grams. It's actually 48.9. It was 1.1 grams less for whatever reason. Sometimes these mass sets, even though they have stamped 50 grams stamped on them, are a little bit less or more. So 0.0489 kilograms is the mass. And here are our two times, T1 and T2. So just make sure that you check the ones that you have written down. And as I said before, the precision point plus or minus 0.0001 second is on the time. For the distance, this distance is the distance between the leading edge and the two leading edges. The photo gate first starts timing when the first edge hits it, and then when it sees nothing, it'll wait to the second time it's blocked. So it'll time from this first edge to this first edge. This was 9 centimeters, 9.0 centimeters, or 0.09 plus or minus 0.001 meters. So that's delta D, and what we're going to do to find the velocities is take this delta D and divide by the time it took for it to go to the first gate and the second gate. And you can see by the time it gets to the second gate, there's a smaller time. That means it's going faster. It's going slower when it went to the first gate. So let's average those numbers, and at the same time, we're going to find the standard deviation. It's if you're going to find the average, you might as well do both at the same time. So I have one of these little simple calculators. It's easy for me to do both at the same time, and I would suggest you do the same. So I'm putting it in stat mode, and I'm just going to input the first column, 0.4122. Each of your calculators is going to be slightly different. So what I would do is look up online the instructions to how to find standard deviations or doing statistical analysis. Okay, so I got all 4 of them in. Now what I'm going to do is find the average. I don't know if you can see this. The average is 0.41825. 0.41825, so it's 0.4183. The average for T1. Then I'm going to find the standard by hitting another button on here. That would be sigma. This one right here. 0.00467. That gives an idea of the precision of the measurement. So if you're doing it on one of the TIs, whichever one you're doing it on, you may have to input these numbers in columns, and if you press all the statistical calculation, you'll be able to see it. You're looking for an S, not a sigma. There's 2 different ways you calculate standard deviation. The standard deviation of an entire you sample it, or you take the standard deviation of the entire body. For instance, if you want to do polling on citizens, if you want to know what every single person who wants to vote for president, you'd have to poll every single voting person in the United States. That really is quite impossible. But there's a standard deviation associated with that. Normally what you do is you do sampling. You take a sample, you take a couple thousand people that are representative of the voting population. That's represented by a different type of standard deviation. So that would be the sample, and usually that's represented by an S. The one when you take every single person, that would be a sigma. So what you're looking for on your calculator for standard deviations, if you see 2 of them, you're looking for the one that says S. This is one you want, not sigma. You don't want the one that says sigma, although some of them have 2 different types of sigmas. So you want the sample standard deviation. So let's do the second stat 1. Okay, so 0.1555, enter. 0.1568, enter. 0.1563, enter. 0.1563, enter. So I've got my 4 numbers, and then the average is, okay, something went wrong. Somehow I got out of stat mode. Okay. I got to put all those 4 in again. Sorry, 0.1555, enter. 0.1568, enter. 0.1563, enter, and 0.1563, enter. All right, so the average is 0.156225, so. And then we've got the standard deviation, which is second and x, this one right here. 0.00054537. It's just, notice how the standard deviation is smaller for T2. You can see that they're not as spread out as for T1. This primarily has to do with the fact when I was releasing it, it was a little fuzzy for where I was releasing it to. The acceleration is not going to be an awful lot different, a couple millimeters, but it is going to affect the first velocity because it's slower, more so than the higher velocity. It's actually very interesting, the error calculations that go on. And if you go into higher levels of science, you have to do very, very careful error calculations and figure out why the spread is higher here than it is for here. And there are different physical reasons for that. Now that we have the averages, let's find our V1 and V2. The velocity for a first gate and the velocity of the second gate. So V1 is the distance, which is 0.090 meters, divided by the average time, which is 0.4183 seconds. So V1 becomes 0.09 divided by 0.4183, the average. So I get 0.2152 meters per second. V2, again, 0.090, that's delta D stays the same for both of them because that's that card that I stuck on top of it. Here, the average time is smaller, it's 0.1562. So let's calculate that out, 0.09 divided by 0.1562, and we get 0.5762. Okay, so that's how you calculate the velocities, V1 and V2, for all of the mass sets. So go ahead and do, we did the first one, now do 20, 40, 60, 80 grams added to the mass hanger. So the next mass we use was 0.0687 kilograms. So and then we use 0.0885 kilograms. You have to do the averaging as the standard deviation for all those, then find the velocity. What we're going to do in the next video is figure out how to find the accelerations from all of these measurements.